Yeah.
Great, thank you.
Yeah, thank you. Hello, everyone. How are you today? Good? Did you have fun this morning? Perfect. Did you have fun this morning? Did you enjoy what you did? Okay, great. So my name is Celine, and I am an engineer at Tesla, and today you will learn a little bit more about what I do and how I actually became an engineer. But before we start talking about that, I will introduce myself a little bit so you get a little bit more about my background. And so, who am I? And here you see me. And as you heard, I'm an engineer. I'm a mechanical engineer, and I graduated from the University of Stuttgart in 2010, which is in Germany. Who of you have heard about Germany? Nice. Yeah. It's great. That's where I grew up, and you can probably hear it from my accent. So, yeah, I'm German. I studied in Germany, and then I came here in 2013 to start working for Tesla. Here you see it. But I'm not just an engineer. I'm also like a person that likes to bike. I bike to work every day. I read a lot, mostly about science, engineering, and then I also like to meet friends and people, talk to people, and go out. So yeah, so there's more than just engineering. But how do I actually become an engineer? So what is the story behind it? It's like, did I just choose, or I will tell you a little bit more about that. So when I was little, maybe 3-4 years old, we have this thing in Germany that's called a surprise egg. Who knows or who has seen something like that? Yeah? Nice, it's great. What that is, it's an egg. You can open it, it has chocolate around it, and there's a small capsule which includes a toy, and there are two options. So the one thing you can get out of it is collectible figures. The other option you have is that they're kind of like things you can build. So I always wanted to have the stuff, not the figures. So I didn't like the figures, they were boring for me. But I like to have the stuff you can build. And if you ask my mother today, she's always telling other people that that's actually one thing where you can see as a little kid, I already was interested in engineering. I wanted to build stuff. I wanted to get the toy that I could make stuff out of it. So what I did, and you can buy them in supermarkets in Europe or Germany. So I went to the shelf where you can get it, and then you can hear in there if there's a figure, if it's just one piece, or if there are multiple pieces. So I always tried to get the ones with the multiple pieces when I had the option to get it. So that was the first kind of sign that I wanted to become an engineer. But then we went further. So when I got older, and I have 2 siblings, I have a sister and a brother, and my brother always got these amazing toys called Lego. So he always had that, but what I ended up with is like I got his toys because he didn't like to build the stuff, he just wanted to play with it. So I built the Lego and used it. And the other thing is in school, what I liked the most was math and science. So yeah, I was mostly interested in that subjects, and for me, like languages were boring. I was not really good at that, but I really enjoyed doing math and science. Yes, and then I am from an area in Germany, which is in the south, here called Baden-Württemberg, and I grew up in the Stuttgart area. And the Stuttgart area had a lot of great engineers in the past, and they did great inventions. So first of all, that's the area where Daimler grew up. It's really close. Like my hometown is 20 minutes from the place where he was born, and he was one of the car pioneers. The other thing is, there's Bosch. Bosch invented the spark plug. I don't know if you've heard about it, but Bosch also does a lot of automotive parts that you cannot see, but you probably have seen dishwashers, washing machines from them, or also power tools. The third one, Porsche, is also originated there. So you have probably seen these amazing cars, and one of the inventions he did was the VW Beetle. Who knows what the Beetle is? Have you seen one? Yeah, see? Like, that's the area where I'm from, and the person invented. Steel, who knows Steel? Some of them, yeah. So he was the guy that invented the chainsaws. So that's also in that area. There are great ones too. There's Fisher. He did wall plugs, and then also like Festo. There's like, it's just 6 companies I named now. There are a lot more. A lot of automotive suppliers and car companies, but also mechanical engineering companies. So when you grow up in this area, a lot of people work for these companies. So you get in contact with those people, you talk to them, their job is to be an engineer. And so what happened to me is a friend of mine that was a little bit older, she started doing mechanical engineering and started to work, started to study that, and I got interested in it. So that was actually like 1 year before I graduated from high school. So I thought, before that, I was more interested in biology, chemistry, and I thought I was doing something with that. But then I said, oh, well, so what are you doing as a mechanical engineer? And that's what got me interested in that field. The other thing is Bosch has day at their company for high school students. So I was able to go there for a day and just look at what they do at work. And that's the time when I got first in contact with hybrid cars. And I thought, oh, this is a cool thing. I want to build hybrid cars or electric cars. So that's also like the 2 things that, I was passionate about, and I think, yeah, let's try it out. Let's try mechanical engineering and see what you can do with it. The other thing is, there was a problem I always wanted to work on, and I also thought we have to do something about it, and it's the climate change. So in school, we heard a lot about erosion, about floods. We had floods in Germany. We heard about melting ice caps and fires. So it's all around the world. All around the world, you can see those things happening. And I thought, what can we do? And there's one, or how can we help to solve, or can I help to solve that problem? What can I do? So I looked at it, and there is one main driver that's, or there's not just one, but one of the main drivers for the climate change is CO2. And CO2 is part of one of the sources of fuels. And the fuels, you can drive cars with fuels. So I thought it would be great if we can do something. So like you can see the hybrid cars, if we can do something to reduce the CO2 and help work on this problem. So that's when I decided, when I did mechanical engineering, I didn't want to really do hybrids. I wanted to do electric cars. And they use renewable energies like water, sun, wind. That was actually what I wanted to do. And so I thought, okay, I started working actually for Bosch 2 years before I joined Tesla and helped there with electronic control units. And we talk actually about my job later, so you can see what I started there and that before I joined Tesla. The third thing is, and if you ask, again, my mother, what I was really good at when I was little was breaking things. It's every time you heard a glass breaking or a plate, it was always me. And if you go home, it's like, and something like that is happening, they just say my name. So you knew that I was there. So I thought, okay, breaking things is actually not a good thing. But what if I can use that in the job, like as a talent versus like something that's actually bad? So you will see what if you take those 3 ingredients, engineering, and add renewable energies to it, or the environment, and the talent to break things, what you end up with is a reliability engineer at Tesla. So now you know the breaking things plays a big role in what I do at Tesla. So yes, so this is the story, like a little bit about me, how I became an engineer. But what do I actually do as a reliability engineer at Tesla? So a lot of you probably know how it is when a car breaks. So you cannot drive it anymore. Who has been in a car that broke down? Nice, a couple of you. So there are like, Yeah, that's not a good experience. I had the same experience. One day I drove to my work in Fremont, like with my old car, a Tesla, and it broke down. It was the most annoying thing because I had a meeting I had to go to, and I couldn't because the car wasn't working. I had to wait for AAA. And what I had to do is I had to make a phone call in the car because I had to call in a meeting, which was so annoying. I said oh man, we have everyone has to do a better job and make sure the things don't break. So that's what I do at my work. I help with the parts, or help to make that the parts don't fail, make them more reliable, right? So, okay, but how can we do that? How can we do or help that the parts don't break? And there are a couple of things you can do. Look at it. First thing is, you start early. If you start building something like you do now, think about them very early, how they can fail, what can we do better? Then you need goals. You have to set a goal. What do you want to achieve? What is our goal? How long does the car need to work? So what is the lifetime? You see it later. The other thing is we need to test it. We need to break it. It has to fail. I have to understand and know how things fail. That's really, really important. It's not, if the things pass, we test them and they're good, you don't know what their weaknesses are. You cannot make them better. So that's really, really something important we have to do. And learn from failures. If things fail, you can make it better. You know how they fail, so find a solution, how you make the things better, how they don't fail. And the other thing is that you can also simulate the real world in a computer, right? So you can do some calculations. You can simulate temperatures or vibration that the car experiences. And then simulate that and see what the impact can be on the part. So that's another thing you can do. Okay, but how do we know how we need to test? Right now I said, oh yeah, we need to test it, we have to break it, but how do we know to do that? And so there are a couple of things you need to think about. The first thing is you have to think about the lifetime. The lifetime of your smartphone might be kind of 2 years. But if you think of a car 2 years, and it's not enough. If your car would break down after 2 years, everyone would be annoyed and the reputation would be bad. So you really have to think about that and make sure, okay, what is the lifetime of a car? Is it 10 years? Is it 15 years? Or is it even longer? And how long does it operate? Is it just 1 hour a day, or do you drive 8 hours a day? And then, yes. And the other thing is think about operation modes. How do you use a car? You do not just drive with it, right? You also park it, and in an electric car, you will charge that. So that's important. You have to think about all these things. How do you use it? Same thing. Are there any buttons you have to do? Do you open doors? How often do you open the doors? So yeah, how it's operated. Then use cases. Think of your parents. Do your parents use the car in the same way? If you think of your mother and your father, is it the case? Maybe not. Then also, who is driving a car? Is there something a delivery service, a taxi, a cab, stuff like that? Different people are using the car, so you have to think about possible users and how can they use the car and help. Then loads. Here, think you all live in California. The weather is nice, sun is shining most of the time, but there are also regions Alaska, where it's pretty cold, or Canada in winters, where it's so cold. And this is a different condition. Or Florida, where it's pretty humid. So this can all have an influence on the car, and that can make it fail in a different way. So you have to understand in which environment the car is used. And then the other thing is, if you know all those things, put them together and try to simulate exactly that usage. So you know how things can fail, and just try to recreate, that's the next one, recreate the field conditions in that test. So think about how it's used, when it's used, in which environment, and try to do that recreate that in a world, in a lab. Just do the same thing you would do outside in a small lab and see what happens before even customers get their car. And then The next thing is we cannot just test one part or one part that goes in the car. So usually what you do is there will be a vehicle level test, but then also there are parts that go in the car. So you will use smaller sections, like could be a key fob, could be just the display. You test it itself. So think of that, and then if you just would test one, you could be lucky and have a good one, right? You could be lucky and have a good one, and it's like excels at what it does. But there are variations. So just if you think of like, neighbors like disease or something, different people get different things. So it's the same thing here. You have to know like how many samples you need to test, and there are ways you can calculate that and put that many samples in the test. Yes, so now you get a little bit of an understanding how you design a test. There are the different ingredients, different parts of it, but how does actually a test look like? What does testing mean? And there's one thing, I think half of you have worked with a Raspberry Pi this morning, right? Yeah? So, and there are a lot of small computers inside the car. And just let's say we take your Raspberry Pi, and we want to put that in a car. So what you need to do is you need to take that component, and like we call it a component or small computer, and we prepare it for the test. So now you write a little software for it, and we want to use the software too inside a test chamber. And in the test chamber, we simulate the real world. And for example, one driver that can make things fail is temperature. So what you would do, you would take your Raspberry Pi, put some software on it, run the software, but you don't just run it at room temperature. You would run it in an oven like you have it at home, like where you bake things in, right? Put that in there for a specific amount of time. It's not just like one day. Sometimes we test them even weeks because we have to cover the whole lifetime of it. So you put it in there, and then after the test duration, let's say maybe 2 months, we take it out and analyze it. So you have to check, is it functional after that? Sometimes you do that even in between, but let's say we just take it out and we do an analysis, and we are kind of small doctors. We have to see, okay, is it functional? If it's not functional, we have to see like, what is the disease? How does it fail? How does it break? We have to analyze it. We have to look on the board. We take now your Raspberry Pi and see, is there, like with a microscope, is there something that breaks? Can we see something from the outside? Maybe if you don't see it from the outside, you would go to an X-ray and use that X-ray to analyze it. Like if you break a bone, then you see, oh, did the board break anything? Can we find it in there? And so that's what you do. So to give you a little bit of understanding, we have to take the part, we have to power it, we have to simulate the software, you write, then put it in a chamber, simulate the real world, like the environment, temperature. It can be also humidity, salt, UV, like solar, the sun, like all kinds of things you can think of. So be really creative what is out there, and then take it out and really understand if it breaks, how does it break, and how can we make it better. Yes. So if you think of all these aspects, like the different things we saw, me as an engineer or other engineers out there, what do they like have in common, or like what are aspects, what are skills they bring? And so when I thought about it, I came up and looked at it and say, okay, what actually are we? There's an engineer, like what does it mean? Like what other skills do we have? And there's like one thing, we are kind of small detectives, right? We have a problem, we have to solve, we have to say, oh, okay, how do we find it? Like what is the solution? Do analysis. So that's one of like, play Sherlock Holmes. The other thing is we have to be really, really creative. I just mentioned there are different load types, different loads that happen outside there. So we have to think about different loads, but also different solution. If there's a problem, how can we find a solution for it? Think about multiple ideas. There's maybe not just one way to solve it, but maybe we can find the best way, or what is the best way to solve it. The other thing is, as an engineer, you also need to be a programmer. Most what I do at my work is hardware engineering, so hardware, but we have to write code, like you do for your Raspberry Pis, to program the chamber, to also do data analysis. We get data out of the test, so do that. So you need to write programs and code. We are kind of, I said, weathermans. We forecast sometimes the future. We can look, okay, what happens? How can things fail? And make it better so that the things don't fail in the future. So you kind of weatherman. You have a map. You simulate the real world, different environments, and look what happens in the future. We are also inventors. So if you have a problem, you have to find a solution and invent something new. And for example, like electric cars, they're pretty new. So they're a new technology, so you have to invent new things if there's a problem that occurs to solve that. We are also kind of managers. And so we have to manage multiple tasks, but also multiple people to make sure they do their job, yes, and they do what they need to do. We are scientists, so if you have a problem and need to solve it, or you have to understand the problem a little bit better, you set up experiments, you do some science and investigate that. There are long-term studies of new technologies you do. You need to understand it. You design an experiment. You design an experiment with different factors. You measure it, all these kind of things, and then do some science. And also, in the end, what I told you before with the test chambers, we are doctors. If something fails, if something breaks, we have to analyze it. We have to find how it fails, what can we help? How can we cure that disease, right? So these are all aspects of an engineer, and me as a mechanical engineer, what I have to do at work, and yeah. So what I wanted to give you today, and maybe also in the future, is be curious, ask questions. If there's a problem, try to understand it. Then also be passionate about what you do. It's not just oh, a teacher tells you to do that. No, you really want to do that. You really want to solve a problem. You do it not just with your head, but also with your heart. Believe in what you do, and then you excel at it. You will be good at it. And then the last thing I wanted to tell you, make it happen. Don't stay with the idea. If you have a good idea, if you have a problem you want to solve, do it. Try it out. If you fail, it doesn't matter. You can learn from it, as we do when we break things. So yes, maybe keep that in mind. That's what I wanted to say. And now I open it up for questions from your side.
Amazing. Thank you so much, Celine. It's really, really cool, everything you're doing. Big round of applause for Celine. Yay! Great. Now, I'm sure that some of you have some questions that you'd like to ask. Oh my gosh, I see hands up already. Okay, so yes. Maya and I are going to be circulating around with microphones, and I'd love to hear questions from lots of you. So I think, Maya, are you ready with a question over there?
What do you think is the meaning of life?
That's a very philosophical question, but maybe the meaning of life for yourself could be that you do something in your life you care about, and you try to solve that problem and make the world a little bit better. Kind of like what I want to do with the climate change, with what I'm passionate about. Maybe you can find something that is for you. And then if you're older and a grandma or grandpa, you can tell your grandkids, oh, look, that's what I worked on. That's what I did. I worked on electric cars and tried to make a better technology and have less CO2. Yeah.
Great, thank you. I've got another question over here.
What was the most fun project you worked on?
The most fun project I worked on is, maybe it doesn't sound like it for you, but it's the testing of the door handle, which was pretty interesting because it's a good combination, and I don't know how many of you know how our door handle works, but it's hidden in the door, and if you touch it, it comes out. So there is a mechanical aspect of it, but also electrical aspect. So you combine mechanical engineering with there's a small little computer behind that, and it's interesting to do both, to do the mechanical side and the electrical side. And we test a lot of electrical things, so it's not just that, but I really like that one.
Okay, right here. Do you have any advice for future engineers/programmers?
So you mean like what you do? Probably really like what I said in the end. Be passionate about it, like try it out. Do it in your free time if you care about it, and maybe also do it with some friends. So it's a lot more fun if you do it with some people together than just alone. And then you can also learn from other people.
Great, thank you. We've got another question over here.
How long have you been at Tesla, and do you think there's any advancements you can make to the Tesla cars?
So I've been at Tesla since 2013, just about 2 years. There are a couple of things you can do with the cars. And you probably have heard about self-driving cars, but then also like make the range better. There's like, yeah, there are a lot of things you can work on, and maybe like if you grow up, you can help do that too. Right here, okay.
What makes you want to work for Tesla?
What makes me want to work for Tesla? So the first thing is really the electric cars. I'm really passionate about that. But then also what I really like at Tesla is the fast pace. I started working for Bosch. I told you about that. They have a lot of processes. It's slower. You have to follow that. But at Tesla, we don't have that. So I really like it, and I enjoy working there. But also the fast pace and the people that all believe in electric cars. So if you work with people there, they all think, yeah, it's a great thing. They want to do it. And there is a lot of energy. You can feel that in with every team you work. Everyone believes in it. There's a lot of energy, and they want to work on it, change it, and make it better. Yep. There are a lot of questions.
I've got another one over here.
Yeah.
What difficulties did you go while trying to become an engineer?
Sorry, can you say it again?
What difficulties did you go through?
So what was the biggest difficulty for me in the beginning when I started mechanical engineering was usually you are one of, there are not a lot of women, and usually if you talk to the men and work with them, they already had a lot of experience with stuff we learned there and did. So I had to catch up, and for me it was like in the beginning it was a struggle. But the good thing is I learned a lot. I learned how to learn myself and get better and understand things. So yeah, that was, I think, really one of the big struggles I had. And then in Germany, it's also that way that we start mechanical engineering from day one, like with a lot of new subjects you never had in school, versus when you do math or physics, kind of, then you know what to expect, and it's like the next step. But in engineering, there were some fields I had never heard about. So yeah, that was like one of the struggles I had. Yep. Yeah.
Who was your role model if you had one?
Interesting. I don't think there is a role model. Alex, do you know? Do I have one? No? See? Yeah, I don't have, so no, there's not really a role model
Is there someone that encouraged you to?
There's no one really that encouraged me to become an engineer. So it was more just the people probably that surrounded me and worked in that field. So, yeah.
All right, we've got another question here.
Do you have a Tesla?
If I have a Tesla? No. I'm working on it, but still, no, I don't have one yet.
Right here.
Yep.
What is it like making a car?
Sorry?
Right here.
What is it like making a car?
What is it like to make a car? What I really like about making a car is that there's a lot of different aspects. If you develop a car, then just think about the product. There's like a screen, so like a bigger iPad or like a tablet. In there are mechanical parts you work on. You get to know so many different engineering things that are really, really great. And then also what you see is like the different use cases, what can happen to a car. That's probably like it.
Great. Here we go. Another question on the other side.
Okay.
Oh,
Over there?
did you ever get like really frustrated, like you wanted to quit something? Like you got really irritated or frustrated?
Like when I was working, what was really frustrating? I think the most frustrating thing for me was it's more about the people than about the work, the technical work you do. And so if they're people you work with, then it's really hard to interact with them. That can be really, really frustrating. Or if you have a manager that wants to do things or wants you to do things in a certain way, but you think the other way is better and you cannot do it your way, that can be kind of frustrating because then you have to follow that instructions. Yep. I think it's more on the personal side than on the engineering side, because if you work on the problem, and you learn to be a problem solver. So for you, if there's a problem, you want to solve it, you want to work on it. So that's not frustrating, but the people side can be frustrating.
Okay.
Yep.
So, did you thought about making your own electric car factory?
If I was thinking of making my own gigafactory, like building it and doing the same.
Your own team? I don't.
So have you ever thought to make your own electric car factory?
Oh, I have never thought about that. But there's a lot, you have to consider a lot of aspects, and it takes a long time to make your own factory. The car has so many different parts, and you need a lot of people, so it takes you a long time to do that. So for me, it was I wanted to work on it, I wanted to start now, so I never really thought about that. But it's a good question.
All right, we've got another question over here.
Yeah.
What kind of things do you have to learn in school to have your job?
In general?
What kind of things do you have to learn in school for your job?
For my job? Okay.
Yeah.
I think what you really need to learn is, from the technical side, is probably you need to know a little bit of math, you need to know a little bit of physics. We call it material science, but it's kind of like chemistry. There is software engineering, like kind of coding, and then, physics has different aspects in engineering, so this is more the technical side, but that's everything you can learn, and if you start mechanical engineering, you will definitely learn that. The other thing is, I think if you're passionate about it, don't give up. Then learn about it, and maybe do even work on your free time. Try it out. There might be struggles, but you can work around that and learn how to solve it, and yeah.
All right, right here.
Yeah, sure.
What's your favorite car?
My favorite car is Tesla. It's still, yes. There's what I'm passionate about, and I didn't talk about it here. It's about fast cars, and I like speed and velocity. But and I really want to see electric cars out there, or cars that are not powered by fossil fuels. So that's what I'm passionate about. So I like fast cars, and if you look at fast cars, I like Tesla ones right now.
Cool. Okay, another question on this side.
Yeah.
Do you know Elon Musk?
I don't know him personally, but you can see him around in the office. So he's not hidden somewhere. So we have this open space office, and he has a desk in the open space office. So he's I think. I don't know him personally.
Okay, one here in the back, over here.
Yep, okay.
Is Tesla working on something right now that they will improve in some time?
Yes. I cannot talk about it, but yeah, they definitely do it. Yep.
Wow, lots of secrets, but exciting.
Yeah,
All right, another
there are
question.
some things I cannot talk about, but yeah.
That's okay. Another question here.
Is Tesla going to be your last job, or are you planning to change jobs in the future?
That's an interesting question. Right now, I really enjoy working for Tesla, and I enjoy what we do. But I'm not sure if it will be the last. It depends. If you would ask me in maybe 5 years, I can tell you. But right now, I really enjoy what I do, and I want to stay there and work for them. So yeah. But maybe if there's a new technology and a new way of doing things, maybe I'm interested in that and want to do it and help with that. Yeah.
Okay, right here.
What do you think about the Nissan Leaf?
So, I like electric cars in general. So the only downside I see is probably the range, but I think it's kind of like if you want to use it as your second car at home, I think it's a good option. Yep. But I definitely one not for the first. We thought about getting an electric car. We just have one car, and we ended up with a Prius, a plug-in Prius. So because of the range, and we had just one car. But I think as a second option, it's definitely one thing. Because it's cheaper and more affordable for people.
Great. Interesting questions we got. Another one on this
very
side.
Interesting.
Do you ever get bored?
No, never ever. So what really happens if you're an engineer, and especially at Tesla, is when you start in the morning, you mostly don't know, you know the projects you work on, but sometimes you really don't know what happens. There are a lot of new things, and it's so interesting because there's a problem, you can help with it, you solve it. There are new technologies you want to work on. So maybe where you can get bored sometimes is in meetings, and if they're a little bit slower, or if there's a topic that you are not much involved with, or if it's more on the purchasing or sales side, then yes. But usually, like in general, I never get bored at work, and there's so many things to do that
What is the project you put most time into?
Probably the most time I spend on is really the door handles, the charge equipment, because I help with that. But then there are so many more things. But I think that's when I started working and helping out with that. That's where I spent the most time on.
All right, I got another question on this side over here.
Do you prefer Windows or Mac computers?
So that's a really, really good question. As an engineer, there are software tools that don't work on a Mac. So what I started with was a Windows computer. Right now I have a Mac at work and at home, so I don't prefer one or the other. I think there are advantages and disadvantages. Right now, what I really like about the Mac is the battery life and the weight. But then also now, if you're used to work with a Windows computer, there are some struggles if you switch over. So I had those, and in the beginning I was really frustrated because I use a lot of shortcuts to speed up things. But yeah, now it's settled, and I still use both. So when I have software tools that just work on a Windows computer, I use Windows, and it's fine. And yeah, now I have a Mac, but yeah.
All right, right over here. Oh, in the front. Here I am.
Here.
Here.
Yeah. Sorry.
Okay. What schools would you recommend for mechanical engineering or auto design?
So
What schools would you?
What schools?
Yeah.
It's hard for me because I went to school in Germany. I cannot talk about schools here. I think what you have to look at is, are there any, what do they do in engineering? Are there any good professors you're interested in, technologies they have? But also, maybe you can talk to my boyfriend who's standing here in the corner. He went to school here. He can talk about that a little bit better. But I think if you learn how to solve problems and you're passionate about it, and then are willing to learn things, it's kind of, you should be good to go. I don't think there are schools, you learn a lot about technologies, and they have great technologies, so you have an advantage, but it doesn't matter that you're not able to learn that when you not go to that school. So yeah, so for me, it's hard to answer because I never went to school here.
Great, thank you. Another question on this side.
Yeah.
Did you find any problem in the Tesla you found really frustrating, or you worked a lot of time on that problem in Tesla?
I don't think it's frustrating. It's very interesting because every time, if there is a problem, you learn the most. that's really, so it's not frustrating, it's more kind of, I really like, I usually tell my test engineers, if we test something and it fails, I say, oh yeah, that's great. Now finally we can learn something from that and help. So it's not frustrating. It's like if there's a big problem, it's more kind of a challenge because you want to solve it and you want to learn from that. Yep.
Okay, right here.
Yes?
Do you like that more car companies are now starting to make more electric cars than just regular gas cars?
So what was the beginning of the question?
Do you like that more companies like to make electric cars?
Yes, I really like that. I enjoy it. And I think we have to work on new technologies to solve, to understand it. So I really enjoy if they start working on it because I think we waited too long. Like, I think it's, yes. But now that they all started working on it and try it out, the only thing what I don't like, there's some companies, they should be more passionate about it, like really drive, but I really like, and we need more companies working on it. Yeah.
I think you're going to that side.
Okay, sure.
Oh, no, we're going over here.
Okay.
What major did you take in college?
In college, I had mechanical engineering, and I focused on kind of material science. There's no equivalent here. That was like a hybrid. It had a little bit material science and testing and stuff. And the other one was mechanics dynamics, like how things move and how you can calculate that and stuff. Yep, that's what I did. But there are more aspects. It's just, yeah. Yep.
Okay, right here in the front.
Okay, sure.
When are you making a sports car?
A sports car.
When are you making a sports car?
When?
When will you make a sports car?
Oh, I don't know. It's kind of like, I think the Tesla is still fast, but I don't know when we make a sports car. That's a good question, though. Yeah.
All right, we have time for just a couple more questions. So
But you'll have plenty of time to ask Celine questions afterwards.
Celine's going to hang out with us at lunch, so you can all ask lots more questions then.
Yeah.
Okay, here we go.
When you were talking about the door handles earlier. So when they open up, because I know when like the car's driving, they're flat, and then when they open up, and then you open the car and then they close again. Are they always unlocked? The doors are always unlocked, or
no?
Oh.
Yeah. It doesn't matter. It doesn't mean if the door handle is out and in that the car, is unlocked.
Oh, okay.
Yeah.
So our last question here.
Do you prefer Apple or Samsung, and why, if you prefer one?
Like all these brand questions, I never had a Samsung device, so I cannot really talk about that. But I have a lot of Apple products. As you can see, I have the Apple Watch, I have an iPhone, I have an iPad, and so. But it doesn't matter that the other, it's more what I like about Apple's products is that they're really easy to use. And even my grandmother wanted to know what the internet is, and we said, oh, a computer is too complicated, we cannot give her that. But what we ended up with, and I said, but we can give her an iPad, it's pretty easy to use, and she can use the web and find out stuff on it, and she really enjoys now the iPad. So for her, even if my grandma didn't grow up with technology or computers, she can use it and work with it. So yeah, it's great, and she doesn't want to give it back to me or to my sister. So she enjoys. That's what I like about Apple. But I cannot talk much about Samsung because I never had any device. An HP computer. Yes, my Windows computer was an HP computer.
All right. Yeah. So I have heard amazing questions, and I can tell that lots of you have more questions, which is great. And so our wonderful rock star is going to stick around with us at lunch. You might be able to get her autograph if you want. You can maybe get your picture taken with her, and I'm sure she'll be happy to answer lots more questions. So before we break for lunch, please give Celine a huge round of applause.
Thanks.